guys, this is part 2 of the video for the May 25th assignment. So that's the start at fractions, decimals, and percents. But this video is starting on page 52. So page 52 is just a really quick review for comparing and ordering fractions and decimals. So it tells you that one way is to put them all on a number line, and the other way is to change them into the same sort of thing. So if I'm looking at 3.25, 3 1/8, then 11 over 3, I can change those all into decimals. So it's 3 and 25 100ths, 3 and 125 1,000ths, and 3 and 6 tenths. And by doing that, I'm able to really easily order them. So remember, this page is all really good information. Please read over it in detail. It doesn't really do any good for me to read it to you, but read over it in detail if you're stuck on any of the concepts. So the first one, it's asking you to use the number line to order each set of numbers from greatest to from least to greatest. So you'll see that the number line, so this is 0 and this is 1. It's broken up into these segments. The first thing we need to know is, what are these segments? So how many segments are there in between 0 and 1? Are there 10? So are they tenths, or are they, what are they? So we're going to count them. 1, 2, 3, 4 gets us up to half. So 8 gives us up to 1. Well, that's perfect because it's already in eighths. All of your questions are in eighths. So it's asking you to find them. So 7/8. So 1, 2, 3, 4, 5, 6, 7. And then we can put 7/8 on that line. And then we can find 5/8, 3/8, and then 10/8. 10/8 is an improper fraction. That means that the number on the top is bigger than the number on the bottom. So the numerator is bigger than the denominator. So we know that with an improper fraction that it's going to be greater than 1 whole. So 8/8 gives us up to 1, so 10/8 is right here. From there, I'm really able to order them from least to greatest. So I just order them 3/8, 5/8, 7/8, 10/8, and it's really clear which one's bigger, which one's smaller. So you're going to do the same thing with part B. You'll notice that when you look at these, you know how the first one was broken into eighths? This one is not. 1, 2, 3, 4, 5 gets us up to half. 6, 7, 8, 9, 10 gives us up to whole. It's already put in tenths so that you're able to order it. When it says 1 and 4 over 10, it means it's 1 and then 4 over 10 over here. All right. It's asking you to compare which one's greater or smaller or equal to. Now this, I tried to draw your attention to it. It says tip, find equivalent fractions. Equivalent fractions are fractions that are the same thing, but as the ones that you have listed here. Okay, so let's do that first one together. It's 11 over 7 and 10 over 9. And it's asking you which is bigger. Now, the first thing that we need to do is put these in fractions that mean the same thing but are easy to compare. So it's hard to find a lot of numbers that both 7 and 9 go into, right? Like if I go in multiples of 7, it takes a long time to find one that's divisible by 9. But I know that if they're hard numbers like that, the easiest way to do it is to say, what is 7 times 9? So for us today, we know that 7 times 9 is 63. Does that sound right? All of a sudden, my 7 times tables are going away on me. Yeah, 63. So we're going to times each of these to find an equivalent fraction over 63. So what did we do to 7 to get to 63? We times it by 9. So we're going to have to do the same to 11. So 11 times 9 is 99. So 99 over 63. What did we do to 9 to get to 63? We times it by 7. So we're going to times 10 by 7, and we have 70 over 63. From here, we know that 70 is bigger than 99. So we know that 99 over 63 is greater than 70 over 63. And we use that here, because remember that these were our equivalent fractions, to easily order them. All right, the next one is use benchmarks on a number line in order to order this set of numbers from greatest to least. I will do number 4 with you. It's the same question, but a little bit harder to set. Okay, so let's go in a little bit closer. The first question thing to put on the number line is 11 over 12. So the biggest thing that we need to know is how much are these segments. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Takes us up to 1 whole. So these are already in 12s. So 11 over 12 is going to be the one right before it. Now we got to find where 1/3 is. Well, if these are in 12s, 4 of them is going to equal 1/3, right? Because 4 gets up to here. Sorry. 4 gets up to 1, 2, 3, 4 here. 1, 2, 3, 4 here. And then another 4 here. So those are in thirds. So we can see that 1/3 gets us there. All right. If we want to measure them in 6, we know that every 2 of these is going to be a 6 because these are automatically in 12s. So every 2 of those is going to be a 6. We want 7 6. So 1 whole is going to be 6 over 6, and we want 1 more 6 on top of that. So 7 6. And then we want 5 fourths. If we want to separate one of these into fourths or quarters, we know that because it's already divided in 12 sections, that 1/4 is going to be 3 of them. So if we want 5 fourths, we go to 1, which is 4 over 4, 1 whole. And then we go to 3 more to get 5 fourths. Now, once we put them on our line, we're really able to put least to greatest, which again is just these in order. So 1/3, 11 over 12, 7 over 6, and then 5 over 4. So you're going to do the same thing with question 3. Oh, and you're going to do it with 4b on the back. All right. Now, it says write each fraction as a decimal and then figure out which one is greater than, less than, or equal to. So the way that we do that is by using division. So we'll just figure it out. I'll do number D with you. So the first thing that we want to do is to say 7 divided by 12. And it's, now this is what we were talking about earlier with repeating decimals. The 5/8 isn't a repeating decimal, but the 3 is. The 3 repeats endlessly. So our answer is 0.583, and then the 3 shows that it's repeating. All right, so between, I just cross this out because so it's not so confusing. So between 0 and 575 1,000ths and 0 and 583 1,000ths, which one is bigger than, which one is smaller than? So we know that 575 would be smaller than, right? Because the 5 is the same. And then we just look at which is bigger, 7 or 5, or 7 or 8. Now, the way that I remember these larger than, greater than, smaller than, or equivalent signs is I always think of it as an alligator, and the alligator's mouth is open to the biggest one, and so that's the 583.
Mr. Jansen, you have a student at the front, Mr. Jansen.
Sorry about that. All right, number 6, use place value to order each set of numbers from least to greatest. So now we got to figure out what are the numbers we're comparing. So 0.97, that's already in a decimal. We want to figure out what 7 divided by 8 is in decimal format. So 7 divided by 8, that's 0.875. Now I would do the same for, oh gosh, I'm not even showing you my page. Perfect. And then I would do the same for 19 over 20, 0.8, 9 over 10. I'd write all those decimals out, and then I'd figure out what it is the smallest of them and what is the greatest of them. This one says to determine a number between the two given numbers. So what it's asking you to do is say, what's a number in between 4/3 and 7/6? Let's see. I always say let's figure out a harder one. So let's go with this one. So let's put it into something equivalent. We see that a whole 5 and a whole 5, those are the same sort of thing. So we want to figure out which is bigger, 1/5 or 0.3. So we want to change it into the same thing. So let's figure out what 1 divided by 5 is. It says it's 0.2. So we know that 5 and 1/5 is 5.2. So now we're going to ask, what is bigger, 5.2 or 5.3? Okay. The next one, Jeremiah thinks, oh, sorry. I'm not asking which is bigger. I'm asking you to find something in between it. So it's really hard to find a number in between 5.2 and 5.3, right? There is no number between 2 and 3. So now we got to go to our half. So in between 5.2 and 5.3 is 5.2 and a half. So the way that we write that is by saying 5.2. We don't need to do another decimal because we're already in the decimals. So we're just going to add in a half, which is right in between 5.2 and 5.3. Because remember, this 5.2, I could add on a 0 there, and I could add on a 0 there, and it's the exact same thing. Because it's on this side of this decimal, I can add in as many zeros as I want. So 5.25 is right in between them. All right, Jeremiah thinks that 3 and 5/8 and 35/8 and 3.58 or 3.58 100ths are equivalent, which means he thinks they're all the same thing. Is he right? So what you need to do is put those all in the same format. So you can choose whether you're going to put them all in fractions or you're going to put them all in decimals, but put them all in something that's the same, and then tell me, are they the same thing or are they different? And how do you know? All right, that is the second part there. I hope that helps.